Hello everyone, very good evening. So let us get started. Yeah, so very good evening everyone. All right, so as part of our agenda, yes, so we are going to start the basic statistics module today. And as part of that, we are going to understand how do we apply the statistics on a given data set. First of all, where do you start? Imagine a data set has been given to you. So how do you analyze the data set? So what kind of metrics or measures you'd compute on the data set? So that is what we are going to understand as part of this basic statistics module. Right. So I would request everyone, please turn off your cameras. Yeah, please. So accidentally when you join, right? So automatically the video so would be switched on. So just check that whether the video is switched on or switched off. Just make sure that the videos are switched off. Right, so we are going to understand the data types as part of this basic statistics like continuous, discrete, nominal, ordinal, interval ratio data types. And then we are going to understand the first, third and fourth business moments. And then the data visualization techniques such as bar plot, histogram. Okay. And then hypothesis testing, then we'll jump into the linear regression. Right. Probability distributions we are going to understand. Right. What is statistics? So statistics is the science of data. It's a branch of the mathematics. It involves collecting, classifying, summarizing, analyzing the data, and most importantly, interpreting the numerical information. Okay. So let us say, what do you mean by collection of the data, classifying of the data? So let us take a simple example here. So in this session, so almost, so in the Zoom session, we have 200 plus people, the students and faculty members have joined, right? And so I can collect the data, let's say, for example, so from the participants, so the data related to the name, okay? And then, so I can collect the data related to the branch, okay? Yeah, excuse me, just give me a minute. Sorry, right. So let's say, for example, we have collected the data from the participants, the branch, okay, location, and the academic, the performance, and all those things. So these are the data that we have collected. Okay, so that is as part of collection of the data. So how do we collect the data? So we can simply roll out a Google form, or we can also send survey questionnaires so that we can get the responses from the participants. So that is how we can collect the data. And then once you collect the data, classify the data. What do you mean by classification of the data? So based on the purpose, based on the business context, what we can do is we can divide. So based on certain parameter, let's say, for example, I want to separately analyze the data related to the electronics branch or electrical branch or computer science or mechanical or civil, right? So different branches or IT. So I can classify the data, and then I can analyze the data, right? So that is what the classification are. We can also classify based on the location, okay, from which location they are from, okay, native place or hometown, or so based on that I can divide the entire data set, then summarize the data. The summarization is basically counted. So how many number of the students are from computer science, how many number of students are from IT, right, and electronics or electrical. So simply I can have the count of the participant from these branches, as well as here also probably I can also collect the age also can collect, and then I can count or I can compute the mean age in these branches. So that is the analysis of the data or summarizing, then analyze. So based on that summarization or summary statistics, we can analyze, then interpret the numerical information, right? So whatever the information that we receive, okay, that we compute. So unless so you transform that data or that analysis into the business interpreted information. Okay, so that means whatever the analysis that we have so generated, that analysis has to be converted into business terminology. So otherwise, the business team, see, at the end of the day, so who are going to consume this analysis? The management, right? So for example, this analysis would be consumed by the college management, or in a real-time scenario, the business teams are the engineering teams, right? So they would consume so this analysis. Now let's say, for example, so they might understand the statistics, or they might not understand the statistics. So if you say that, hey, I have conducted the hypothesis test and the p-value is, okay, 0.01. So if you send like this, just like this, okay, so they would not understand what do you mean by p-value, what do you mean by hypothesis testing. So what you have to do as a data scientist, so you have to convert this statement, the statistical analysis or this statement, into the business statement. So how this p-value would affect the business. Okay, convert your statistical analysis or the summary into the interpretation information, so that can be consumable by the business teams. So at that time, you have to wear the hat of the businessman, and then you have to transform your statistical information or analysis into the business terms, and you have to explain to the business teams. So this is the most important the activity out of all these things. For example, if you anyone who knows how to apply these tools, so they can easily apply all these things, they can do the analysis. But the most important task is this. So how to convert so that analysis into the business terminology. So unless you have the good experience in that domain or in that business, you will not be able to do this. So this is another important skills that you have to focus on, not only the statistics but also how to make this understandable by the business teams. That is also very, very important skill, right? Right. So some of the content, whatever we are going to talk, so has been taken from this book. This is a standard textbook actually. So many of the universities are so prescribed for the statistical course, the complete business statistics. Okay, so if you are interested more, probably you can download this from the internet. A PDF, free PDF copy is available. Just you have to type the complete business statistics. Okay, and we are going to use the software Python and Jupyter Notebook as well as Spider. So these are the two, the Python engine that we are going to use, and Anaconda. That's how actually we are going to download. I'll show you how to download that. So probably tomorrow. Right. So now two important concepts when it comes to statistics: population and sample. So what is a population? The population so is when you consider all the items in a given scenario, in a given situation. Let's say, for example, yeah. So let's say, for example, there is a factory. This factory is producing laptops. Okay, so this factory is producing laptops, and if I consider all the laptops so that this factory is producing, then I can call that as the population. Okay. And if you consider so all the people who are living in this country in India, then you can call them as population of India. So if you consider all the people who are living on this earth is called as population. Okay, so that is the population. If you consider so all the items, products, or the people, so in that so area or in that definition, then you can call that as a population. And what is a sample? The sample is, so if you take a handful of representative data points, so from this, then that is called as sample. Let's say out of 100,000, yeah, 100,000, the laptops which are being produced on daily basis by this factory. Then if I consider, let's say for example, So randomly 1,000 laptops. So randomly I'll pick 1,000 laptops. Then that would considered as sample. Okay. Then so why do we have actually these two different terms? So why do we have to take the sample? What is the necessary for that? Okay. Let's say, for example, let us take an hypothetical situation wherein we are producing some pens. Okay. So pen manufacturing company, and this company has got an order from a client. So the client said that, hey, my pen should be around, okay, so 8, let's say 8 inch to, okay, and 10 inch. Okay, so this is the specification, and any pen so which does not fall under in this category, so 8 to 10 inches, then that would be considered as a defect. I'll not pay for those pens. Okay, so that is what the customer has given the specifications. Now this factory has to produce the pens so which falls under in this category, and any pen that below 8 inches and above 10 inches would be considered as a defect. Customer will not pay for those pens. So that means that is loss for the company. Now what they have to do? So they have to monitor each and every pen whether that pen falls under in this specification limit or not. Let's say this company is producing so 1 lakh pens every day. Now, is it possible for this company to monitor each and every pen has the length of the pen is within these limits? So this would be an operational challenge. So it is a very challenging task. So I would not say this is impossible task, but this is a challenging task. Now, to avoid that, to work around for this procedure is what we do is we can set a frequency limit at every 1 hour. What we do is, so I'll take, let's say 1,000 pens. So at every 1 hour, I'll take 1,000 pens. Then I'll examine whether these 1,000 pens so are within this limit or not. So how many of them are within this limit and how many of them are outside these limits. And every 1 hour I'll take 1,000. So this is what this sample means. So that is what we are considering as sample. And this 1 lakh, or you can say a time frame. So within that time frame, how many pens which are being produced, you can call them as population. And if you take the representative of the data points, so from this population, you can consider them as sample. And on this sample, we would apply our statistics to understand how this process is going on. How, so this 1 lakh, so 100,000 pens are the specification limits. So when you analyze this data, we are going to understand, so these population aspects. Okay, so that is how, so we would come up with the sample statistics or sample concept, right? And so what are these, the charts? So these are the bars and all these things. So how do we get this? Now you are talking about this, the pen length, right? Now what I will do is we are saying that 1,000 pens will be sampled for every hour. So first pen, what is the size? Let's say length of the pen is, let's say 5, for example, 8.5. Second pen, okay, so 9.1. So third, okay, so 10.2. So like that, for all the pens, I'll collect the lengths, right? So simply I can represent this data in the graphical manner. That is what this is. Okay, so this is a simple histogram. We are going to discuss that. Right? So this data set, and we can simply plot it on the histogram form, and this is called as sample. And population is when you have all the 100,000, 1 lakh, the pens length, then we'll get like this, a distribution so of the population. Right. Now, for this sample as well as population, we can compute a few metrics and measurements. For sample, we'll call them as statistics, sample statistics. Right? The sample statistics, we can compute the X bar sample mean. That means whatever the values that I have. So simply I can compute the mean or a simple average. And I can compute sample variance, that is S square, and the sample standard deviation, small s. So these are called as sample statistics, and we'll see how to compute these things. And when it comes to population, we'll call them as parameters. So parameter, we'll see why we'll call this as a parameters. And yeah, these are not. So here population mean, that is mu, population variance sigma square, and population standard deviation sigma. These are the Greek letters. And here for sample, we will use English letters X bar, S square, and S, and here we'll use Greek letters. Right. And when it comes to statistics, so we have two kinds of statistics. We can divide statistics into two categories. One is descriptive statistics, the other one is inferential statistics. Right. What is a descriptive statistics? Let's say, for example, I have been given a data set, a simple data set. So data set means we'll have rows and we'll have columns. So let's say your professor or your manager has asked you to analyze this data. Analyze the data. That means you have to do analysis. You have to generate some insights out of this data. What is the starting point for that? Where do you start? The starting point is this descriptive statistics. When a data set has been given to you, the first step, doesn't matter what kind of analysis that you're going to do, what kind of the situation that you are in, the first step so towards this analysis or insight generation is descriptive statistics. First you have to apply this descriptive statistics. And what is that descriptive statistics? Compute the mean, compute the median, and go for visualizations. So just slice and dice of this data set, go for the different visualizations like pie chart, bar graphs, and histograms, and also compute the mean, the median, the skewness, curtices. That means by applying these kinds of measures and visualization techniques, we are going to understand this data set. When you say understand, yes, probably when we have the column like, let's say, age, what is the average age? That gives me some insights about the data set that we are analyzing. Okay. So when you say, for example, we also have a column called salary column. This implies data set, let's say, for example. Then I can compute the average salary. Then I get to know that average age and average salary. That is another insight. And I can go for a visualization technique like histogram for this salary column. Then I can see the distribution of this column. So by applying these measures in order to understand this data set is called as descriptive statistics. So this is my data set. The main objective of applying the descriptive statistics is to understand the data set by various metrics, various measures, and various visualization techniques you would apply on this data set, and you would be able to understand this data set. So that is called as descriptive statistics application on the data set. All right. Then the statistics is inferential statistics. The inferential statistics is basically, let's say, I want to find out, for example, the average age of Indians. So this is what actually my objective is. So how do you find out this average age in general scenario? What is a rudimentary method or brute force method? Generally, what we can do is, so we can go to each and every person who is living in this country and record their age. First person, okay, second person, third person, fourth person. So like that, I can collect. So 130, okay, so 130 crores people. Then I can take the average. Then that would be the average age. So this is one of the methods. So it's a brute force method. But do you think this is a viable option for a company? For a company, this is not at all a method that they can pursue. They need more simple solution, more viable solution. So it requires a lot of money and effort, right? So to collect each and every the Indian age. So this is not a viable solution for us. Then what is the other solution that we have? Let's say I have the population. So this is where actually we have the average age. This is my population data. What we do is, I'll take the random sample, so from this population. So this is my sample now. This is my sample. Now what I would do is I would apply the inferential statistics. Inferential statistics. When I apply inferential statistics, then I would get the ability, or as part of, as output of this inferential statistics, we would get the estimate of average the age of this population. Let me repeat it. We would like to find out the average age of this population, let's say India. So how do you do that? So we discussed one brute force method, and that is not going to work out for us. So the other method, the practical solution. So here is, take the random sample from this population. So once you get the population, and using this inferential statistics, we can estimate the average age of this population. So using this inferential statistics, we can estimate the average age of the population. That is what the inferential statistics means. So what are the examples of inferential statistics? So we have, so confidence intervals, okay, confidence intervals, hypothesis testing. So these are the examples of the inferential statistics. Right. So this is the basic difference between the descriptive statistics and inferential statistics. So the descriptive statistics would be applied on the sample data, okay, on the sample data, and we'll understand the insights about the sample data. But the inferential statistics, okay, we would apply on the sample data, but we would comment about the population. The comment are, so we will try to estimate the population parameter. So that is what the inferential statistics is. Right. Let us get started with the first statistics, that is descriptive statistics. Okay. Yeah. So we eventually will get into the inferential statistics also. So as part of this descriptive statistics, let us understand the data types. So when you collect the data, whatever the data that you collect, the data has to fall under these categories: nominal, ordinal, interval, and ratio scale. So these are the four categories. So where the data has to fall under, no matter what kind of data that you collect. The first one is nominal data. So what is the nominal data? So the name suggests nominal name. It's a label. Like, so how do you call your friends? By name, right? So the name is nominal data. Or the chairs, laptops, tables, pens, right? So the name given to the things are the humans. So that is the nominal data type. Your previous degrees, your degree, BTech. So that is a label given to the 4-year study, right? So BTech or BSc or BCom or whatever it is. So those things are called as, are considered as nominal data type. And ordinal. So ordinal, again, if you see ordinal or ordered data, can be ranked, ordered. University rankings, business school rankings, or the customer survey, where customers would give us the highly satisfied, okay, satisfied, neutral, dissatisfied, a highly dissatisfied, right? So these we can arrange them so in particular order. So start with the highly satisfied, satisfied, neutral, like that I can arrange. So these ratings, so this also comes under ordinal data. Okay, right. Coming to interval scale. Interval scale is the magnitude between any two intervals, so will be same. For example, if I take the temperature, I have 0 temperature, 1, 2, -1, -2. Right? So if you see the interval between these, the severity between these different intervals will be same. That means if I move, for example, so from 1 to 2, so how much magnitude that I would experience the increment of the temperature, the similar kind of experience I will get. So when I move from 0 degrees to 1 degree, the magnitude or the severity of increment of the temperature would be same across the different intervals. Even if you move from -2 to -1, yes, the magnitude is same from here to here and from here to here, right? So in these intervals, the severity of the magnitude is same. So that is interval scale. And for example, the time also. So 12 to 1, okay, and 1 to 2, 2 to 3. The time amount of time is same in this interval. Right? So this is called as interval scale data type. And coming to the ratio scale, the ratio scale is normal kind of a data where we use and capture on daily basis. For example, the weight, height, okay, and the currency. So these are all the data types that comes under ratio scale. And most of the statistics and calculations can be applied on this ratio scale, because there are certain limitations. You cannot apply all the statistics and the calculations on this nominal data, because this is basically a name. You cannot apply mean on this data. Can you compute mean for the names, right? So can you compute mean for the degrees? We cannot compute, right? So there are certain limitations. You cannot apply all the statistics so on this data, but you can apply all the statistics on this ratio scale, right? Right. Then other dimension of these data types is continuous and discrete. So whatever we have discussed in the previous slide, so there is one dimension of categorization of the data types. And here we have another dimension is continuous and discrete data types. And what are these? So this is most important. We are going to use more and more about this continuous and discrete data, because based on this categorization, we would apply certain techniques, statistical techniques and algorithms. Right. First, let us understand what is a continuous data. The continuous data is if you can write any quantity or any measure, so in terms of decimal values, then we can call that as continuous data. For example, if I take the temperature, so I can express the temperature quantity, so like this 25.50, okay, and I can express the height, let's say 15.2 feet or centimeters or whatever it is. So I can express in this the decimal values. Still this makes sense to us. So any quantity, if you can express in this decimal format, then we can call that as a continuous data type. Like for example, time, currency, I can say $15.2, right? So that makes sense, okay. And the length, so these are all comes under continuous data types, right? So coming to discrete data, the discrete data where we cannot express any measure or the quantity in terms of decimal values. For example, if you see here, we have 4 laptops. I can express this number of laptops. I can say either 0 or 1 or 2, 3 or 4. I cannot say 1.2 laptop. So it doesn't make much, right? So this doesn't make any sense in this for this kind of the quantity. And here also you have the tie cars, right? So I can say 5 ties or 6 ties or 7 ties. So we cannot say 7.5 ties. It doesn't make any sense. And here is a funny example: beatings from wife, or so since you are the students, beatings from mother, right? So is this what kind of data? Is it a discrete data or continuous data? Quick response, guys. What do you think? The beatings from wife or mother? Yeah, discrete. Great. Right. So it's a discrete data type. Exactly. Right. A quick check. Right. So you can post in the chat window or in the YouTube comments. So what kind of data type it is? So for continuous, just you can type C, and for discrete, you can type D. Okay. So the first question is, volume of a cereal box. Is it a discrete or continuous? It is continuous. Good. And speed of a car, speed of a car is continuous. Population of a town, discrete. Very good. Length of a crocodile, length of a crocodile, length. Okay, I see mixed response. So it cannot be discrete. Length you can express in terms of decimals, right? So I can say 15.5 centimeters. It is continuous, exactly. Continuous. Number of matches in a box, discrete, exactly. Temperature of oven, continuous. Number of goals in a season, number of goals in a season, discrete or continuous. Discrete. Right. Then we have number of shirts, discrete. Excellent, guys. Fantastic. So you got the point. Right. Right. Now we are going to understand the measures of central tendency. So remember, guys, so we are discussing descriptive statistics. Okay, so we are discussing descriptive statistics. As part of this descriptive statistics, so we are discussing all of these things. And as we discussed, we have two kinds of statistics. So one is descriptive statistics, the other one is inferential statistics. So as part of this descriptive statistics, we are going to discuss about measures of central tendency. We are going to discuss that. Okay. And so as part of this statistics, we have so two kinds of statistics we are going to discuss about. So descriptive statistics, the other one is inferential statistics. As part of this descriptive statistics, we are going to discuss about measures of central tendency, measures of variance, and then we'll discuss about the visualization techniques. Okay. So once we complete these things, measures of central tendency, variance, and visualization techniques, then we'll move to inferential statistics. Okay. So until and unless you hear about the inferential statistics, you should assume that we are discussing about the descriptive statistics. Okay. So these are the major parts in the descriptive statistics. Once we complete this, then we'll move to this. Right. So as part of the descriptive statistics, the first one is measures of central tendency. So as part of that, we are going to discuss about the mean, median, and mode. These are the three measures. So are part of this the measures of central tendency. And I know that you know already how to compute a simple mean, right? So simple mean is nothing but summation of all the elements in a data set by total number of elements in the data set. Okay, so the formula is x bar. So x bar is equal to sigma xi by n. So I equal to 1 to n. So the xi summation of sigma xi is nothing but summation of all the elements in the data set by total number of elements in the data set. So if you see here, we have 4 elements, 4 data points in the data set. Now, how do you compute the mean for this? The mean is simply just add them up, all of these elements, divide by 4. So that is where actually we'll get the mean for this data set, that is 8.62. And this another data set, just compute the means. sum up all the elements by total number of elements are 5 divided by 5. That is what a mean of this data set. Mean is nothing but a simple average, right? So we know how to compute a mean, but there's a problem with this mean actually. So what is the problem? So there is something called as outlier. Okay, there is something called as outlier. So what is outlier? The outlier is if you have any number, so yeah, if you have any number, so that is very far from the rest of the group. Let us say I have data set like this: 1, 2, 3, okay, 4, 5, and all of a sudden I have a number called 100. This is my data set, and which one is odd man out here? So which number that you think is a completely different than the other data points, other numbers? 100, exactly, right? 100. So why do you say that 100 is a completely different than other data points? Is if you see the on the numerical scale, so if you place all the data points on the numerical scale, 1 2 3 4 are pretty close to each other, 1 2 3 4 5. But what about 100? 100 is somewhere around here, very far from other numbers. So in this case you can consider the 100 as outlier, right? Now any data set that has the outliers, when you compute the mean, then the mean would be inflated. That means mean would be drastically changed. So when we have the outliers in the data set, let me show you a simple let me take a simple data set and let me show you that. So let me populate a simple data set here. Okay, 1 2 3 5. So let us compute mean for this data set. So how do you compute? Just sum up all the data points. So divide by total number of elements, and we have direct function formula in Excel. We can compute that. So 3 is a mean for this data set. Now let me do one thing. So let me populate data set 2, a second data set 2, and let me change this number to 100. The fifth element, the 5 to 100. Now what is the mean here? The mean is 22. That means the change of a single number, just one element of change to 100. And what is the change in the mean? The mean has been changed drastically. That is 22. That means the mean is extremely sensitive towards the outliers in the data set. Right? And also, what do you mean by mean? Why we are computing mean first of all? So as we said, mean is a central tendency measure. That means when you compute mean, this mean should represent the middle portion of the data set. So all the values must be in and around of this value. That is the expectation when you compute the mean. Simply, if you have to understand this, the data set roughly at a high level, we can go for mean. Then I can understand that, yes, okay, the value is mostly in and around of this mean value. And that is true for this data set. When I say mean is 3 for this data set, yes, of course, the values are near to the 3, right? Near to 3. I can say 1, 2, 3, 4, 5, which are very close to 3. But what about this value, 22? Do you say that 22 is very close to these values or even this value? No. So this 22, so neither close to this value or nor this value. That means mean is not a good representative when you have the outliers in the data set. Right? So that is where actually there is a problem with the mean. When you have the outliers in the data set, so mean is not a right representative for this kind of data set. Then what is a right representative when you have the outliers in the data set? Then we have the next measure called median. Right. So median. So to solve the problem of outliers in the data set, so we have median. Right. So to compute median, so we have two cases. So here we have first case and the second case based on the number of elements we have in the data set. Okay. So let's say, for example, I have a data set like this. So 2, okay, 3, 1, 5, 4. So this is my data set. So to compute this median for this data set, what we have to do is first you count the number of elements in the data set. How many number of elements are there? We have total 5. So 5 is odd. So odd. 5 is odd, right? So it is not this 5. Total number of elements you have to count it. So total I have 5 elements are there. So 5 is odd number. So in that case, so I'll go for middle value so of this data set after sorting the data. Sort this data set. So that is 1, 2, 3, 4, and 5. So these are sorted order, the data set. So once you sort it, since the total number of elements are odd numbered elements, so take the middle value. So that is called as median. Now for this data set, what is a median? Median is 3. So that is the first case. And what if actually if you have even number elements? Let me include one more element here, 6. First, sort the data set 1, 2, 3, 4, 5, and 6. Just sort the data set. And when you have even number of elements, then take the two middle values average. So take the average of these two middle values, then that is the median for the data set. That is 3 plus 4 by 2. That is 3.5 is a median for this data set. Right? Right. So 3.5 is a median for the data set. Now let us go back to the example, earlier example. Let us see how median can solve the problem of where mean could not solve it. Right. Now tell me what is the median for this data set? DS1. 3. Exactly. For second data set, for DS2, what is the median for this data set? Still 3. Exactly. Right. So that means no matter what, whether you have the outliers in the data set or we do not have any outliers in the data set, doesn't matter. So median gives you, yes, the set of measure. So when you say right set of measure, the central tendency, right? And median is robust towards the outliers. So the next one is mode. Mode is its most frequently occurring value is a mode for a data set. For example, if you talk about the first data set, this one, which value, which element is occurring most of the times? 6 is occurring actually. 6 is occurring 3 times. So for this data set, 6 is a mode for this data set. Okay, simple frequency measure. So how many number of times a value is occurring, and if it a value is occurring more number of times, so that is the value of the mode. And we have bimodal and multimodal data sets. What do you mean by bimodal? So bimodals are, so there are more than one element would occur at the same frequencies but highest frequencies. Meaning, just consider this data set. So in this data set, you can see a 333. So 3 is occurring at frequency of 3 times, number of times 3, and 444. 4 is also occurring 3 times. That means more than one element so is occurring with highest frequency. So that is 3, and both are at same frequencies. So 3, 3. And any other elements, so 1 is occurring only 1, 2 is also 1, 5 is also 1, like that. So this 3 is highest frequency. These two are occurring with this highest frequency. Then I can say 3 and 4 together act as a mode for this data set. Right. And here we have multi-model datasets. Multi-model datasets are more than two elements would occur, so with highest frequency. So you can see here 2, 2, 10, 10, and 3, 3. So 2, comma 3, comma 10. These three together would act as mode for this dataset, and that is multi-model datasets. Right. So a quick comprehension what we discussed so far. Okay, we discussed about the data types. So we have seen nominal, ordinal, interval, and the ratio scale data types, and also we have seen continuous and discrete data types. And then we have discussed about the two kinds of statistics: descriptive statistics and inferential statistics. And we started our discussion with the descriptive statistics. As part of descriptive statistics, okay, so we have discussed measures of central tendency, and as part of this we have discussed about mean, how to compute mean and median and mode. Right, so these are the three measures that we have computed as part of measures of central tendency. Right, now we are going to discuss about measures of variance or measures of variability. So as part of this we are going to discuss about variance, standard deviation, and range. Yeah. So these things we are going to discuss now. All right. So let us take a break now, a 5 minutes break, quick break. So now it is 5:52. We will resume our discussion at 5:57. Okay. So at 5:57 we'll discuss. We'll start our discussion again on measures of variability. Right. Yeah. Hello all. Yeah, let's continue our discussion. Right. So now we are going to discuss about the measures of variability. So as part of descriptive statistics. So first, let us understand the motivation behind these measures of variability. So when you have already discussed about the measures of central tendencies like the mean, median, mode, why do we have to study, or why do we have to learn about the measures of variability? Okay, let us understand uh, the practical usability of that. Let us take an example here. Okay. Let us say a river is there. Okay. And in that, water is flowing. Okay. So there's a question, guys. Listen carefully. You have to answer this question. Okay. Right. So water is flowing in this, and the speed of the water is not that danger, so people can walk and all those things. Yes, and so there is a person, so who's standing on one side of the bank, the river bank. So this person does not know how to swim, but this person wanted to cross. So this river, he wanted to go to the other side of the river, so on foot. So there are no boats and all those things. He wanted to go on foot. Now, so there is a signboard. The signboard says that the average depth of this river is 4.5 feet. Okay, 4.5 feet. This is average depth. And this person is well above this 4.5 feet. Let us say this person is 5.5 feet height. Now this person thinking actually is so this person can go ahead and cross the river. Okay. So on foot, or so he should not go cross the river. So that is what actually this person's dilemma. Now the question is, what would you advise this person? Whether this person can go ahead and cross the river, or so he should not cross the river. You can post your responses in the chat window. Okay, so most of the answers are okay, he can cross the river. Okay, unable to advise, cross. Okay, don't cross. 4.5 is average. So depends on standard deviation. Good. Yeah, mix of answers. Right. Now let us discuss. So let me give you the scenario here. If you see, the average depth of this river is 4.5. So let's say, for example, the depth of this river near to the banks, so will be so very low. So when I say very low, the depth is not that much. Let's say 0.1 feet. Okay, 0.2 feet. Okay, then 1 feet, 2 feet, 3. Okay, so 8 feet. So like that we have the depths at various places in the river. Now here we have 8 feet at one place, that is the middle of the river, and still we can get so 4.5 as an average if we arrange the numbers in these other the places. Now as per the logic, actually if you go by this 4.5, this person is well above this 4.5, 1 feet above, then we are wrong, right? So because so this 4.5 we can get infinite number of ways Just it's all about the number, arranging the numbers, so in various places here. But what happens actually if the depth in the at the middle of the river is 8 feet? It's a dangerous situation for this person. That means the average alone is not sufficient to take the decisions. This is just average, guys. So average does not give you the complete information about a situation. Something else we need. Okay. So what additional information is given to you, then you would be able to take the decision firmly and confidently. The additional information that we need is the maximum depth. What is the maximum depth of this river? Then we can take the decision. We can advise this guy so confidently. Hey, based on that, hey, don't cross or you can cross. That means, so this average, yes, so this doesn't give us complete information. We need some additional information to take the decision in this problem. Right. So that is one thing. Now let us understand one more example here. The other example is related to the pharmaceutical industries, the clinical trials, for example. So we are hearing a lot of clinical trials, right? So because of this COVID vaccine, yeah. So related to that, for example, a pharmaceutical company, and so they have a team of some people, and they are developing a drug, a medicine that regulates sugar content in the blood. Okay, and a healthy person sugar content should be around 100 some units. Okay, let us not bother about the units. Let's say, for example, just 100 should be there. And so this team of the pharmaceutical the engineers, so they have developed a drug so that regulates and that makes sure that the sugar content in the blood is around 100. So that is what so they are telling. Now the company went ahead with the clinical trials. As part of the clinical trials, that tablet has been given to the various patients. And for each patient, so they have collected the blood samples and they measured what is the sugar content in those patients. Okay. Now, for every hour, they have collected the blood sample and they've measured the sugar content in the blood. So first hour, second hour, third hour, fourth hour, like that. For 24 hours duration, they have collected the blood samples and we have values here. At every hour, yes. So we have got the blood samples and sugar content in the blood. Now, when we have taken the average here, the average value is, let's say, 100.1. So this is the sugar content, average sugar content in the blood after giving the medicine to these patients or volunteers. Okay. Now the question for you guys is, see, the average value is 100.1, and which is very, very close to 100. So which is the healthy person's sugar content level. And can we go ahead and approve this drug? And can we say that, okay, give it to all the patients? Can we pass this drug? So what is your comment? Okay, no. Why? Okay, the answer is right. Now you are in the right direction, but why? Or first of all, we can't say, right? So that's also right answer. Can't say. Okay, right. Average is misleading. For example, yeah, this is a drug one, for example. Now I have another drug. Okay, so this drug, the same procedure. So we have given to the volunteers, and the first hour, the sugar content is, let's say, for example, 100.2. The second hour, so 100.1, so 99.9. Okay, so 100.3, so 100. So like that, I have the values all around this 100. And then average is also, let's say, for example, 100.05. Now, can you tell me what about this drug 2? So can we approve this drug 2? Yes, that's right. Now let us go back to the drug 1 again. See here, so I did not give the data in this. So we have computed the average, and that average is 100.1. So this 100.1 again, so we can get infinite number of ways, right? So I can arrange all these numbers, 24 numbers, and I can get 100.1 as an average. So what happens, for example, so the first hour is 100, the second hour is, let's say for example, 80, the third hour is 200, fourth hour is 20, fifth hour is 5, so 500. So like that I have the data, but still we can get 100.1 average. Now if you see here, the 100, this is fine, but what happens if the sugar content, sugar levels drops down to 80? And what happens if it shoots up to shoot up to the 200, then 25? So these are the dangerous situations. Actually, these are critical situation for the patients. And here, so here all the values are around 100, and the average is 100. In this case, yes, we can go ahead and approve this. What is the difference between this data set and this data set? So what do you observe about these data sets? So why we are saying that this is a good drug, good medicine, and this is not a good medicine? Okay, deviation from the mean, consistency, variation. Yes, exactly. So if you closely observe these individual elements in the data set, you see here what is happening. 80 to 200, a big jump. Again 200 to 20, a big jump again. 20 to 5, 5 to 500. What are these called? Fluctuations. There is a good fluctuations like this. Fluctuations. So these are also called as variance. And if you see here, the fluctuations are very low because the values are very close to each other on the number scale. The fluctuations are low. The deviations from the individual elements, so with respect to mean, is also very low. Right? So these fluctuations and the deviations directly related to the variance of the data set. In this data set, we have high variance. In this data set, we have low variance. That means, so we can get to know these fluctuations, the deviations directly using the variance. The variance will give us information, so how the numbers are fluctuating or how the numbers are consistently across some value or around some value, right? So that variance is important. So with a simple average, so we cannot take, or we cannot get the comprehensive information about a problem, but you also have to include the variance also to take the decisions, right? So that is where actually we would apply variance to take any business decisions. It is also equally important. Now, so let us see how do compute, yeah, how do we compute the variance for a given data set? Right. So a simple data set, let me take here. So 1, 2, okay, 3, 4, and 5. So this is my simple data set. The formula to compute the variance, first let us compute the variance. Okay, sigma, okay, xi minus x bar square by n minus 1. So this is the formula to compute the variance. Okay. So what is this x bar? X bar is nothing but the mean of the data set. So we can compute the mean for this. So this is 15 by 5, that is 3. So this x bar is 3. What is xi? Xi is nothing but the individual elements in the data set. Simply we can plug in the values in this equation, and I equal to 1 to n. So total number of elements in this data set is 5. So that means 5 times we'll have here xi minus x bar. This x1, we can say x1 x bar plus x2 minus x bar square. So like that we have 5. So x5 minus x bar square by 5 minus 1, 4. So here we have first element is 1 minus 3 square, okay, plus 5 minus 3 square, 4. So when you compute this, so this is 4 plus the second one. So 2 minus 3 will get here, right? So that is 1 plus 3 minus 3 0. Then 4 minus 3, that would be 1 plus 5 minus 3, 2 square, that is 4. So 4. So this would be 10 by 4, that is 2.5. Right. So this is the variance for this data set. Fine. So the application of the formula is fine. But now let us understand again in the deeper. So what is happening when you apply this formula to a data set? How do you interpret this value 2.5? What is happening when you're applying this formula to the data set? Let us understand that aspect. Right. So again, let us take this data set 1, 2, 3, 4, 5. So compute the mean here. Mean, that is 3. So if you see the formula again here, so xi minus x bar, okay, so n minus 1. What do you mean by xi minus x bar? One element, so x1 minus x bar. That means I'm going to subtract the individual element from this mean. What do you mean by subtracting one number from other number? That means you are measuring how many units these two numbers are apart on the numerical scale, number scale. I have 1 here, 0, 1, 2, this is 3, 4, and 5. When you say 1 minus 3, that means simply we are measuring, so how many number of units apart these two numbers on the numerical scale. How many units we have? 1 unit, 2 units. That means 1 minus 3, these two numbers are apart 2 units. And 2 to 3, so here we have 1 unit, 1. 3 to 3, the number itself is there, so there is no distance, right? So these are 0 distance. 4 minus 3, again 1 unit, 5 minus 3, 2 units. So since we are finding out the distances, right? So it would be, it should be consistent. It should be 1 minus 3 or 3 minus 1. That has to be applied consistently. When I say 1 minus 3, this would become minus 2 minus 1, right? So to avoid that, what we do is we'll square it off. If you say, for example, minus 2 here, minus 1, then you sum it up, you'll get the 0. First of all, minus 1, minus 2, so you cannot say those distances would make any sense, right? To avoid these things, what we do is we'll square it off to get rid of algebraic sign here. Square and square. So this is what 10, whatever we have discussed, whatever we have got here. 10, just to normalize this value, the 10, we will divide the total number of elements minus 1, that is 4. So this is what actually we have got, 2.5. So that means the variance is nothing but, so how far these individual elements with respect to mean of this same data set. If the elements are very far, so from each of these, the individual element with respect to mean, then the variance will be very high. It all depends on the distance, right? So how far this element with respect to mean, how far this element is with respect to mean. If these distances are more, then you can say the variance will be more. If these distances are very, very low, the elements are very close to each other, then the variance or deviation will be very low. So that is how actually we can interpret the value of the variance. Again, when it's interpretation, this 2.5 doesn't give you any information as it, the standalone value doesn't give you any information. When you compare, so this data set's variance with other data sets variance, that's how actually we can take a decision. Okay, so always the variance and standard deviation has to be compared with a reference value. So I can compare this data set 1, the variance value, with the data set 2's variance value. Then I can understand whether the numbers are very close to each other or the numbers are very far away. So when compared to each and the individual elements in the data set. Okay, now a quick exercise here. I have 3 data sets. Data set 1, I have 5, 8, 2, 3, 9. Data set 2. Again 5, okay, 100, 20, okay, 500, 1000. Data set 3. Okay. So if you have understood the concept correctly, then you should be able to tell me now, so which data set will have the maximum highest variance without computing? Just examine the numbers and tell me, just post in the chart window, which data set will have the highest variance out of these three data sets. Excellent, guys. Yeah, data set 2. So we'll have a highest variance because you can see the numbers, the fluctuations, right? The fluctuations directly contributes to the variance or deviance. So we can see that. So 520, 500,000. So these are the differences, the distances directly contributes to the variance and deviance, right? And what is the variance for this? The data set 3? 0, exactly. The variance for this data set 3 is 0. So just you see the word variation, variance first, variance, variation, that is nothing but the variation, change. What do you mean by change? See, if you see here, this one, do you see any change from this one to this one? There is no change. You see any change from this one to this one? No change. This one is equal to this one. See, let's say for example, you have a laptop. You have two laptops. These two laptops are exactly same make, same configuration, same price, and same dimensions, and everything is same. If all the dimensions, everything is same, you would say these two laptops are same. There is no change between these two laptops. Yeah, that means here also you have one, and this also exactly the same one. There is no change from here to here. There is no change from here to here. That means there is no variation from here to here. No variation, no variation. There is no variation. Then the variance for this data set is 0. All values are same. We can also verify by simply computing, applying this formula also. The mean for this data set is 1, right? Then compute. What is the distance from here to here? 0 distance. Distance 0, 0, 0. So 0, 0, 0 by some value would become also 0. Right? So whenever you see a data set, a column which has the same values across all the rows, then simply you can say, so the variance or deviation for that column is 0, and that column is not going to be useful for us. Yeah. Right. So this is what the variance all about. Right. So the next one is range. Standard deviation. Yeah, we did not discuss, right? The standard deviation is nothing but the same formula, whatever the formula that we have used, s square. So the variance, the sample variance would be denoted by s square. Okay? And the standard deviation is small s. Okay? So that means the square, so we'd send it to the other side of the equal, then that would become square root. So that is what that quantity is called as standard deviation. So earlier example, we have got 2.5 as a variance for 1, 2, 3, 4, 5. Okay. And for this, what is the standard deviation? Simply square root of 2.5 is a standard deviation. Okay, so both conveys similar meaning, but which one will use mostly? So both can be used, but mostly we'll use standard deviation because of the same units we will get. Let's say, for example, I have a data set related to kilometers. So kilometers every day, let's say for example, a person or a traveler is traveling. Now, if I want to find out the variance for this data set, the kilometers data set, then I would get, let's say for example, so 21.5. Yeah, 21.5. What are the units for this? For the variance, because this is s square. You see, we are subtracting the same quantity with the mean of the quantity, then we are squaring it. That means the units also would become squared. 21.5 kilometer squares. The variance is this. Okay, so this is not in a convenient form, convenient way to convey the message, right? So in order to remove this, get rid of this, so we'll have the standard deviation where we'll square root of 21.5 kilometer squares. So that is square root of 21.5 kilometer. Okay, so that's how we can convey more meaningfully when you use standard deviation. Yeah, there are other statistical reasons also. Let us not get into that now. Right. So the third measure is, yeah, right. So the third measure is range. Okay. So range is a simple measure. So where we subtract the maximum element in the data set minus the highest value in the data set minus the lowest value. So max minus min is a range. So max minus min is a range for a data set. Okay, so that is a simple method to identify, again, to understand the spread of the data. So in the data set, so how the spread is the data set. Let's say, for example, here we have maximum of 9 and minimum of 2. So 9 minus 2, that is 7. 7 is a spread, is a data set. Let's say, for example, you have 100 here. So 100 and another element is 2. So in this case, you can say 98 is the range of the data set. So that's how you can compute the range and understand it. Now, so one more thing I think I skipped here. We have these computations, variance, standard deviation, different formulas for population and the sample. Okay, so for sample, what are the formula that we have used? So that is for sample, s square and s. Okay, so where we have n minus 1, n minus 1. For population, everything else is same. Only in place of n minus 1, we'll have n here. Yeah. So because, so there are various explanations are there. So one thing is, here we are using, so one parameter, that is x bar. So because of that, we are losing 1 degrees of freedom. So that's where actually here n minus 1 will use. Okay, so here also we'll use n minus 1 because already we are using x bar here. In a calculation, we are losing 1 degrees of freedom. Yeah. So that is, again, it's a different concept altogether. Right. So just you can remember that for sample, we'll have the n minus 1. For population, we'll have n here. Right. So here is a simple exercise. So in class exercise for variance, standard deviation, range. So you can take any data set. You don't have to work on this. You can take any simple data set and just apply these formulas, compute the variance, standard deviation, and range, and try to understand. So what is happening in the formula, right? Okay. Right. Now we are going to discuss about the visualization techniques. Okay. All right. So visualization techniques. As part of that, we are going to understand uh, what are the visualization techniques we can use and how do we interpret those visualization techniques. So let us consider a simple data set, GMAT scores, so of an MBA class. And these are the scores. So as we know, the maximum score would be 800, right? And any score that is more than 700, so would be considered as a very good score, right? And the scores are like this for each of the students. This is student one score, second student, third student, like that. We have different students scores. Now, if you want to comprehend these scores, if you want to understand uh, more in depth how these scores are, means let's say I want to understand roughly. So, how many of the students have got more than 700 score, or how many students have got more than 730 score, or how many of them are more than 650 score? So, if you see the data set as it is, this data set, would you get that idea? No. Okay, we will not get so that information if you just stare at this simple numbers. What do we need? We need the visualization, graphs, right? The first visualization technique that we can use is a bar chart. The visualization techniques is the best methodology to understand any data set. See, whatever the measures that we have computed, the mean, median, mode, or the variance, those gives you some information about the data set. But those also does not give you complete information. Okay. The best way to understand the data set is plot it. Use the visualization techniques. That is the best thing to understand your data set. Right. So as part of that, your first technique is bar chart. The bar chart is a simple frequency methodology to understand so how many number of students or how many number of data points are there at one particular value. So how do we understand this? You see at various scores, these on x-axis we have the scores. On various scores, we have some bars. What are these bars? The bars are nothing but these many students have got the scores. The length of the bar represents number of students have got that score. So roughly 180 students have got 710 score. 700 roughly 60 students have got. So for each bar, you can just check with the y-axis and you can understand how many number of students have got that score. Now, overall, so if you see this, so almost okay, above 650, 90% of the students have got. Just checking with these graphs, we can say that almost more than 90% of students have got more than 650. And more than 700. So probably we can say that so 40 to 50% of the students have got, or more than 50% also we can say, more than 50% of students have got more than 700 score.